This is Mr. Holsey with H Squared Sufficiently Understood Science, and today we're going to learn how to balance a chemical equation and justify the law of conservation of mass. So the law of conservation of mass states in a chemical reaction, matter cannot be created or destroyed. It can only be changed. And so essentially what that means is in a chemical equation, the reactant must equal the product. Now, they're not going to be necessarily in the same molecules they were before, but you'll have the same number of elements that you began with. So there are 4 steps to balancing a chemical equation. The first is to set up your equation by figuring out what elements there are, to count the number of atoms you have on both sides, balance by changing the coefficients, and that's going to be very important because we cannot change anything except the coefficients, and recounting if we after we've changed those, and start the process again if it still does not balance. This is kind of a trial and error, but I'm going to give you guys some tips on how to make this as easy as possible. So let's take a look at this one and figure out if it's balanced. So let's count the atoms. So on our reactant side, there are 2 nitrogen atoms and 2 hydrogen atoms. But on our product side, we have 1 nitrogen and 3 hydrogen. Well, that seems like a really easy fix. All I got to do, mark out that 3 subscript and put in a 2, right? Now I should be perfectly fine. I could even put another nitrogen in there. But the problem is I'm violating a fundamental law of the universe. I can't do that. I can't change my subscripts. So this is a unbalanced equation, but it doesn't mean that we can't balance it. So the reason why we can't change those subscripts is because atoms can only bond in certain ways. So whenever they're bonding together, we can't suddenly just throw in an extra atom and expect it to fit because of those valence electrons. And so we have to go by those rules. So subscripts are the small numbers below an element, and the coefficients are the large numbers in front of the formula. We can't change the formula, but we can change the amount of a formula we put in. And so it's kind of like baking a cake. You can add a little bit more sugar, a little bit more flour, but you can't change what you're adding. I can't all of a sudden put in something else to try to change things. So in balancing equations, we can only change the coefficients. So back to the balancing. So we can only change the coefficients before the symbols. And so if we take a look at this, we have a coefficient of 1 in front of each of these. And so we can actually go in and change the number of coefficients, the number of molecules, and try to get a different result. So let's go ahead and practice this. So we're going to put them in the middle. Like I said in the last video, I think it's a lot easier to put it in the middle rather than doing 2 separate columns. So I'm going to do it like that to show you guys how I do it. So we need to find out do both sides have the same number of atoms, and we've already determined that that on one side you have 2 nitrogens and 2 hydrogens. On the other side you have 1 nitrogen and 3 hydrogens. So when it comes to balancing, we have to change the coefficients, and it's easier to start with the lower number and build it up first. So for example, right here, I have 2 nitrogens on one side and 1 nitrogen on the other. it's easier to go ahead and try to make that one nitrogen match the two nitrogen. And so what we're going to do is we're going to add a coefficient. So always move from small number to large number. It just makes things so much more simple. And so I'm going to put a coefficient of 2 in front of the product side. And so that's going to change my nitrogen to 2, but it's also going to affect the hydrogen on the product side because it's a molecule. And so now we're doing distributive, and it's going to change that hydrogen to a 6. Well, now our nitrogens check out, but our hydrogens no longer are not checking out. So let's go ahead and add a coefficient on the reactant side. And so I'm going to add a coefficient of 3. That's going to change that to 6. And now they both check out. So we've balanced this chemical equation. So remember the 4 steps. First, set up your equation by figuring out what elements are there. Count the number of atoms on both sides to determine if they are balanced or unbalanced. If unbalanced, we can balance it by changing the coefficients and recounting our elements. And if one coefficient isn't enough, we simply start the process again and keep adding coefficients until we get something that works. So we're going to list the elements below the equation. So we're going to do a little bit of practice here. So we have hydrogen and oxygen. We're going to count the number of elements. So oxygen on our reactant side has 2. On our product side, there's only 1. Hydrogen's 2 and 2. So hydrogen checks out. Hydrogen's good to go. But this oxygen, not so much. So we've counted it, we've determined that this is an unbalanced equation. So we're going to balance it by changing the coefficients and recounting. So we're going to have to change this one first to make it match. So we're going to add a coefficient of 2. And so that's going to change our oxygen now to 2, but it's also going to affect the hydrogen on the product side. So now we have 4. So we have to make the hydrogen on the reactant side now match 4, because our oxygens are good. It's the hydrogens that are the problem. So we're going to add a coefficient to the hydrogen on the reactant side. We're going to add a coefficient of 2, and that's going to change that to 4. It checks out, and it is now balanced. Let's try a little bit more difficult one. So we're going to set up our equation. We have magnesium, chlorine, and hydrogen. We're going to count the atoms on either side. So we have 1 magnesium on each side, 1 chlorine on the reactant side, 2 chlorines on the product side, 1 hydrogen on the reactant side, and 2 hydrogen on the product side. And so now what we'll do, we know that this one checks out, but these two, not so much. So we're going to change this. So we need to have at least 2 chlorines on the product side, or the reactant side. So simple enough. We're going to add, we have 1, so we need to have 2. We're going to add a coefficient of 2. So I'll change the chlorine to 2, so that all checks out. And it's going to affect the hydrogen on the reactant side as well, and make that 2. And look at that, that's all we had to do. 1, 2, 3, we check out. So it is now balanced and done. We just had to add one coefficient. So let's try this one really quick. Sodium, chlorine, and hydrogen. So we're going to start with hydrogen in this case, since it's the only one unbalanced. So this is the only one that's unbalanced right there. So we're just going to start with hydrogen. Now once again, we're going to start with the lowest number first. And so we're going to go ahead and click, go ahead and change the coefficient to a 2. Now that's going to change the hydrogen, but it's also going to change everything else in that molecule. And we have chlorine change from 1 to 2. So now this is no longer good. This one's good, this one's good, but we're going to have to make some changes to the chlorine on the product side. So we got to bring that up to 2. So we'll add that coefficient, but it's also going to affect the number of sodiums, which is now 2. Now we have to fix another issue. So we have to fix the sodium. So we'll put coefficient of 2. And there we go. We check out 1, 2, 3. So we have all of those ready to go. And so this has been our tutorial on balancing chemical equations. This is Mr. Holsey with H Squared Sufficiently Understood Science. Remember to like, share, and subscribe. Also hit the bell notification to know when we post a new tutorial. And check out some of our other content that's popping up right now. All right, catch you later.